Hi, Algebra 2. This is a video of the answers for the review sheet for test number 1 for Unit 11. Please make sure that you've tried this review sheet on your own, and at this point you're just checking your answers. You can use the review sheet if you need to when you're taking the test. So the test is going to be on a Google form, and the link will be on the website that you can use. And, if there's a question that's similar, then use this review sheet as a model. So the first question just wants to know the reference angle for an angle that measures 285 degrees. So I drew a picture of an angle that's 285 degrees. So of course this is 90, 180, 270. So it's a little bit past 270 degrees. It's over here in the fourth quadrant. Reference angles are always based on the x-axis. So I'm at this point, since I'm closer to 360 than I am to 180, I'm going to do 360 minus 285. So basically, I'm trying to find what this angle right here is going to be, and that's going to be 75 degrees. So 75 degrees is my reference angle. Question 2 wants to know which of the angles is equivalent to a radian rotation of 5 pi over 4. So I'm basically changing radians back to degrees. So the way I convert radians to degrees is I multiply by 180 over pi. So I take that 5 pi over 4 and I multiply by 180 over pi. The way I remember it is if I wanted, first of all, it's on the reference sheet, so you don't have to worry about memorizing it. But if I want to change from radians to degrees, I need the pi's to cancel, so I'm multiplying by 180 over pi. If I'm changing from degrees to radians, I want pi in the answer, so that's when I multiply by pi over 180. So in this case, my pi's cancel. 5 times 180 is 900. I have 4 on the bottom, and 900 divided by 4 is 225 degrees. 3 wants to know which of the angles is coterminal with the one that measures 130 degrees. So coterminal means it's another angle whose terminal ray will be in the same exact position. So what you do is you do 130 minus 360. This is one possible angle that's coterminal because negative 230 would start here and it would go this way and it would again end at the same point that 130 ends at. Now that answer wasn't here. So you also have to do 130 plus 360 degrees. That's 490, and that is choice 2. Because basically 490 degrees starts here in the same place. It goes 360, and it's here, plus another 130. It will be in the same exact spot that 130 is. The unit circle has which of the following equations? X squared plus y squared equals 1. That is an equation for the unit circle. Here's my x, here's my y. Unit circle has a radius of 1, so I can just use my Pythagorean theorem right there. Now there are 2 ways that I can do question 5, and one is using that equation for the unit circle, x squared plus y squared equals 1 squared. I have an x coordinate of negative 3/4, so I'm plugging in negative 3/4 for x, and I am solving for y. So negative 3/4 squared, if you follow back down here, is 9 over 16 plus y squared equals 1. I'm solving for y, so I'm going to subtract 9 over 16. I changed this 1 to 16 over 16 because that's equivalent, because I want to subtract 9 over 16, and that gives me 7 over 16, but again, it's y squared, so I have to take the square root of 7 over 16, which is equal to the square root of 7 over 4. So that's one way to do it, and maybe that's a little bit easier, but I've also drawn out a picture for you so you can see this visually. So basically, if I have an x coordinate of negative 3/4 in the second quadrant, so I have negative 3 and I have 4. Okay, so this point right here is negative 3, 4. And I am trying to find, remember, x is my cosine. Cosine is adjacent over hypotenuse. So basically, the adjacent side, if my angle right here is negative 3, and then my hypotenuse is 4. So I'm using the Pythagorean theorem in order to find this missing side right here. Okay, again, so cosine is adjacent over hypotenuse. So when I draw my right triangle in the second quadrant, I know to put the 3 here because that's adjacent. I know to put the 4 here because that's the hypotenuse, and I have to find this missing side, which when I do the Pythagorean theorem comes out to be radical 7, and I'm trying to find the y-coordinate. The y-coordinate is the sine, and sine is opposite over my angles right here. Opposite is radical 7 over hypotenuse, which is 4. So see how I get the exact same answer, whether I'm using that equation for the unit circle, x squared plus y squared equals 1 squared, or if I'm drawing it, that triangle in the second quadrant and using the Pythagorean theorem to find that missing side. You have to be careful when you're drawing it that you're putting everything in the right position. I had cosine, or x is the cosine, so I knew to put the 3 and the 4 here, and I just used the Pythagorean theorem to find that missing side. But number 5 is choice 1. Number 6, I have an angle that has a positive cosine, so I drew my little all students take calculus. So if it's a positive cosine, cosine is positive in the first quadrant because everything is positive in the first quadrant, and it's also positive in the fourth quadrant. I have a negative sine. Well, sine is negative in the third quadrant and the fourth quadrant. So which of these is true for both? Positive for cosine and negative for sine, and that is in the fourth quadrant. 7, which of the following angles is the cosecant function undefined? Cosecant is the inverse of sine, so it equals 1 over sine. This would be undefined if sine was equal to 0. A fraction is undefined when the denominator equals 0. So basically, when does a sine equal 0? So I just drew a little x and y axes right here to find out what sine of 0, 90, 180, and 270 are. So this is a 0.10, this is a 0.01, this is a point -10, and this is a 0.0 -1. I want to know when sine is equal to 0. Remember, sine is your y. xy, x is cosine and y is sine. So right here, sine is equal to 0, so that's 180 degrees. Okay? This is another place where sine is equal to 0, but that choice was not there. Question 8, we don't have to do. That was question 5. It just got repeated. I'm not sure why. This is a non-multiple choice version of question 5, but it's the exact same question. I get an answer of radical 7 over 4. Number 9, the tip of a pendulum. So this right here, so this is the tip of a pendulum. It's swinging and through an arc whose length is 8. So the length of this arc right here is 8. And the radius of the pendulum is 26 centimeters. So this radius is 26. I want to know what radian angle did the tip rotate through and round my answer to the nearest hundredth. So my formula for this is S equals R theta. S represents the length of the arc, and that was 8. R represents the radius, and that was 26. And theta is the angle in radians. So all I'm doing is plugging in the length of the arc, the radius, and I'm solving for theta. So I divide by 26, and I get 0.307. And they wanted that answer to the nearest hundredth. So my answer is 0.31. Okay, the answer is right over here, 0.31. 10 wants to know the minimum and maximum values that sine of A can have. Sine of an angle has to be a number between 0 and 1. It can be 0 and it can be 1, but it has to be a number between 0 and 1. It can't be bigger than 1. On the unit circle, the radius is equal to 1. Sine is equal to opposite over hypotenuse. So basically sine is equal to y over 1. So if the radius is 1, the radius is the hypotenuse. The 1 has to be the biggest number in this triangle. The hypotenuse is the biggest number. So y would have to be a number that was less than 1. On number 11, angle A has a terminal ray that falls in the fourth quadrant. And the cosine of A is 5/9. So I drew a picture here for us. I know I'm in the fourth quadrant. The cosine of the angle is 5/9. Cosine is adjacent over hypotenuse. So cosine is 5 over 9. I do the Pythagorean theorem to find that missing side. So 5 squared plus b squared equals 9 squared. 25 plus b squared is 81. I'm solving for b. I'm going to subtract 25, and I get b squared is 56. So So I take the square root of 56. B is equal to the square root of 56, and I do simplify that. 4 times 14 is 56, and 4 is a perfect square, so that equals 2 radical 14. I do have to remember that I'm in the fourth quadrant, and sine is negative in the fourth quadrant. So my answer is going to be negative 2 radical 14 over 9. Okay, now how did I get that? Sorry, I skipped a step right here. The sine is equal to opposite over hypotenuse. So once I know that this side is 2 radical 14, its sine is 2 radical 14 over 9, but again, I'm negative because I'm in the fourth quadrant. Another way to do that is over here. I'm going to use that x squared plus y squared equals 1 squared, or cosine squared plus sine squared equals 1 squared. So cosine is my x, 5/9 squared is 25 over 81. I am going to solve for b, so I'm subtracting 25 over 81. So I change this 1 to 81 over 81, and that gives me 56 over 81. So b squared is equal to 56 over 81. B is equal to radical 56 over 81. And radical 56 is equal to, we did that over here, 2 radical 14. So there's my answer again. And once again, I am in the fourth quadrant, and sine is going to be negative in the fourth quadrant. So don't forget the negative. So this might be a little bit easier if you want to do it this way. This way is more understanding the whole concept of the unit circle and placing it out in the right position and trying to find that missing side. 12 says, in which quadrants would sine and cosine have the same value, meaning they're both positive or both negative? So they're definitely both positive in the first quadrant. Sine is positive in the second quadrant. Cosine is negative. And in the fourth quadrant, cosine is positive. In the third quadrant, tangent is positive. That makes sine negative in the third quadrant, and it makes cosine negative in the third quadrant. So they're both positive in the first quadrant, and they're both negative in the third quadrant. And the last page, I want to explain why cosine of pi equals -1. So I'm going to change this actually to an angle, degrees. So pi is equal to 180. Now I have cosine of pi. I multiply that by 180 over pi. The pi's cancel. So cosine of pi is actually 180 degrees. So 180 degrees would be this point right here. And I drew again my x and y axis, and I plotted all the points for 0, 90, 180, and 270. So the cosine of 180 is equal to -1 because cosine is my x coordinate. 14 would like me to find the exact value of sine of -120 degrees. Remember, if I have negative degrees, I'm starting this way and I'm going clockwise. So I drew a picture so we can visually see what the sine of -120 degrees is. It's right here in the third quadrant. I need to know the reference angle. The reference angle is always in regard to the x-axis. So I do 180 minus 120. So my reference angle right here is 60 degrees. And the sine of 60 degrees is radical 3 over 2. That's something that you should have memorized, but you have that chart also in your notes. And sine is negative in the third quadrant, so my final answer is negative radical 3 over 2. 15 wants to know the exact value of secant of 135 degrees. So I drew a visual of 135 degrees. The reference angle, 180 minus 135, is 45 degrees. So basically, I have the secant of 45 degrees. Now, secant is the inverse of cosine. So I'm doing the cosine of 45 degrees. I look on my table, or I have it memorized, is radical 2 over 2. I am in the second quadrant, so I am going to be negative for cosine and for secant. And then once I know that it's negative radical 2 over 2, secant is the inverse. I have to flip that. So it's 2 over radical 2. So all I did was take this answer that was right here. I'm taking this answer and I'm flipping it. And then I have to rationalize the denominator. So I multiply it by radical 2 over radical 2. And I get 2 radical 2 over 2. And those 2's can actually cancel. I'm just looking at this. But don't forget that it is negative. So it can just be negative radical 2. The negative 2 and the 2 can cancel. So it's just negative radical 2. 16, I want to know where cosine is going to be negative because less than 0, and where cosecant is going to be positive. So cosine is negative in the third quadrant right here and in the second quadrant. So right here, I'll highlight those for you. Cosine is negative in the second and third quadrant. It's positive in the first and the fourth. And cosecant is the inverse of sine. So it's going to follow my rules for sine. So I want to know where it's positive. Cosecant is positive in the first and the second. So my answer will be the second quadrant. 17, the terminal side of an angle passes through the point negative 512. What's the value of cotangent? So I drew myself a little visual right here. Negative 512 is this point. I'm going to put the little green dot right there because it's negative 512. All right. The missing side right here would be 13, although you don't really need to know that. Tangent is opposite over adjacent. Cotangent is the inverse, so it's adjacent over opposite. So based on this angle, adjacent is negative 5 and the opposite is 12. So that's my answer right there, negative 512. 18, expressed as a function of a positive acute angle, the sine of negative 230 is equal to. So I drew a little visual right here. Negative is starting here and going clockwise. It's negative 230, so I'm going past 180. How much past 180 am I going? I'm going 50 past that. But I want to know which is a function of a positive acute angle. So I add 360 and I subtract 360 from that. I'm sorry, this is for the next problem. Let me finish this one up. So this is the same thing as sine of 50 because my reference angle right here was 50 degrees. I did 230 minus 180 and that's 50 degrees. So that's number 18. This right here is for number 19. I want to know which coterminal with an angle of 125. So you add 360 and you subtract 360, and those are the two possible angles that are coterminal because coterminal angles share that terminal ray. They have it, that terminal ray is in the exact same spot. So this one is choice 2. And last question, an angle drawn in standard position has a radian measure of 2 radians. It would terminate in which quadrant? So I want to change to degrees. So I'm going to take that 2 radians, change to degrees by multiplying by 180 over pi. That gives me 360 over pi. So that's 114.59 degrees. So basically 2 radians is about 114 degrees. And if I draw a picture of 114 degrees, I am here in the second quadrant. Okay, so those are the answers to the review sheet. You're now going to take your test, which will be a link for you to do, and it will be a multiple choice test on a Google form.